this problem where we are validating binary search tree. So here are the properties of binary search tree, and basically for a given node on the left side for the binary search tree has to be smaller on the left side and right side has to be bigger. So in this example we can see that for the given node 2, left side is 1 and right side is 3. So this is a valid binary search tree. And in this case, let's take an example of this one. So for a given 5, left side is 1, which is smaller, that is valid binary search tree, and then right side, which is 4. This is not valid because right side has to be bigger than a given node. So this is not a valid binary search tree and will be returning false. And here are some constraints. So value could be a range of from here to here. So let's jump into coding. So in order to solve this, we can see that we need to do in order traversal where 1, 2, 3, these will be in ascending order. So every time when we see a current node, we just need to compare against previous node, which is really small number previous node. So if previous node becomes bigger than the current node, that means this is not a valid binary search tree. So let's define our so in here I'll be giving initiating a minimum value of long because of our constraints here. We could range up to here, and I'll be creating my helper method and passing our root and previous, and in the end also in here what I'm going to do is I will just create a memory and boolean memory which will be our answer and assign true. I will be just returning is this. So I will take an assumption that it will be true unless there is an invalid binary search tree properties we see. So let's define our helper method. So we are taking tree node. We will be taking long previous, and also we'll be taking answer with the boolean, which will hold our final answer. So if root equals our base case, we're returning it, and we'll be just using depth first search traversal. So in order traversal, for in order we need to see the left side first and then the root itself and then right side. So let's start with left side. Then so we start from left, and now we're here. What we are going to, when we come to our root, then we'll be comparing our value against the previous one. So root if root that value becomes bigger than previous value, then we will reassign our previous value to that value. Otherwise, our answer will contain false. We'll traverse the right side of it. And in the end, we'll hold our answer here, and that's what we're going to return. So let's run it. Now, as we can see in here, so for time complexity is O of n, where n is all nodes in a binary tree,